Good morning. We're going to start the review for Chapter 11. This is a very quick chapter, not too hard, I think, overall. 11.3 is probably the hardest, so that's where I'll spend most of my time. So, review Chapter 11. So these are all square root functions. That's the whole point of this chapter. And first, you need to know the basic format. And that is, so we've got the parent function y equals square root of x. But that's the function if you just do a very, very simple graph right here, starting at 0 with no changes. But the full function, if you include all of the different possibilities, is x equal a square root of x minus, and I'm gonna just put these all in different colors, h, let's see, and I'll just do k in black, plus k. And just to review, a means a stretch or a shrink. It also means a reflection if it's negative. So that is what A does. H moves it right to left, right or left. And K is going to move it up or down. Okay, so that's really important. And I'm going to use let's see, y equals the square root of x minus 1 plus 3. Now I'm not putting an a in front. Well, maybe I am going to put an a in front just to make it real, so you can see the whole package. So knowing this, if I look, the 3 is going to move it up and down. So, and this is also going to tell me my y-intercept. So this function is going to start at 3. The negative 1, or the 1 here, sorry, is going to tell me side to side. So this is going to also start at x equals 1. And the 2 tells me this is a stretch, so it's going to be steeper than this. Let's see what the data gives us, though. And I was always going to do the table before I draw it. Otherwise, we run into trouble. Okay. Now I'm going to put things in for x, by the way, that are going to make my life easier. So if I put in 0 for x, what happens? 0 is my first go-to. I should always do that. But there's a problem when I put in a 0, because right here, I can't, because I'm going to end up with a negative square root. So that means basically 0 is not an option. Can I put in a 1? Yes, I can put in a 1 because I get a square root of 0 times 2, which gives me 0. That's perfectly workable. And of course that works well because that tells me I'm starting at 3 as my y-intercept. Let's see, and then if I put in a 2 in, I get 2 minus 1 is 1 times 2 is 2 plus 3 is 5. And I can't put in any negative numbers, so I think my next number up, I'm going to try to get a perfect square in here. The next perfect square up is a 4. So if I want a 4, I need to put in a 5 for x. 5 minus 1 is 4. Square root of 4 is 2. 2 times 2 is 4 plus 3 is 7. So I have enough points now. And I can see that I need to go up to 7 on the y-axis and up to 5 on the x-axis. So my first point is, let's see, 2, 3, 4, 5, 6, 7. I always come short, don't I? Okay. my first point is 1 and 3. 1, 3, 2, 5, and then 3, 7. Now look at this. You can see right away that this is steeper than the parent function. You can also see that it has been moved over from 0 to 1 to the right. And sorry for saying the y-intercept. This means that this is where the y's start. So it is up by 3. If there were no 1 here, it would be on the y-intercept. So what does this say about the domain and range? These functions, the domain and range is really important, and you have to give them on your test. So here's the domain. The domain is all the x values, right? Well, what can you say about the x values? Well, you can't have any x value that's smaller than 1. So you have to say x is greater than or equal to 1. To find this out, you have to go to the smallest possible x value allowable. So make sure that you keep going until you hit that negative square root, because if you don't, you'll get the wrong domain. For that domain, the range is going to be y is what? Where do the y's start? Well, there's no y, right? You can't start. This is not something that continues. It's almost like it's not a segment because it's a curve, but it cannot go below 3. So your y is greater than or equal to 3. So that is your domain and your range. And when you give me the graphs, you have to give me both the graphs and the domain and the range. Okay, this example is going to cover numbers 5 and 7 as part of your review. So now let's look at 11.2. And I'm going to pause after 11.2 because I am, as I said before, going to focus almost all of my attention, not all, but a lot of my attention on 11.3. So in 11, let's try the first example, which is 7 square root of 5 minus the square root of 45. And this is just the example that's given on page 755 as how to simplify an equation that has a square root. Well, first thing is you have to simplify both, and you cannot simplify this one any further, you're stuck. But you can simplify this one, and we have to break it down into its elements. So I'm just gonna leave this one alone, but just recopy it so I don't forget that it's there. And in here, I'm gonna break this down into square root of 9 times 5. Well, I'm going to again rewrite this, and I know the square root of 9 times 5 is the square root of 9 times the square root of 5. That means I know that the square root of 9 is 3, and I have the square root of 5 left over. I'm now as simple as I can get. That square root of 5 is now simplified to 3 square root of 5. And I now find I have basically like terms. I have something times the square root of 5 minus something times the square root of 5. And because they're like terms, I'm allowed to subtract them. So I end up with 4 square root of 5. So this is the example. And this is for the section 11.2. So let me look at some of the evens. And I won't do all of them. I'll just do a couple. And let me start with number 8. Square root of 98. Now, to do this well, you should right now stop this video and do square root of 98 and then come back and see if you did it right. But I'm just going to go on from here. So square root of 98, what can that be broken down between? Well, quite frankly, like I won't necessarily know it looking at it just as is. So what I'll do is I'll just sort of do my little division on the side. And let's see, and I'll use my calculator. So what is 98 divided by 2? It's going to give me 49. Well, that's quite helpful because 2 times 49, and here right away I can see, oh, that is a perfect square. That's going to be very useful. So I'm going to take that and I'm going to say, okay, I can break this up as square root of 2 times the square root of 49. And I know this is going to be a 7. So square root of 2 times 7. But the convention dictates that the 7 goes first. So my answer is 7 square root of 2. Okay, that's number 8. Let's look at number 12. Number 12 tells me the square root of 5 over x squared. When I have a quotient, I can break it up with square root on top and square root on the bottom. And I can deal with each of these separately. Well, this is as simplified as it gets, but this is not, because I have the square root of a perfect square. And I know that the square root of x squared is just x. And so this is my answer. Okay, I'm going to stop there, and I will pick up with 11 point, the word problem 11.2, and then 11.3 in the next video.